Jarmo Harju. I work for a company called Expericon. I don't work for Tampere University, as I would say many here. But my main assignment for the past year has been this Supermatrix project that has been going on since beginning of April last year. And it's a 3-year project, so I will spend the next 3 years or so with this project. My main responsibility in the project is virtualization, data centers, security, and legislation. So my background is not with the communication technologies. I hope you don't ask too many difficult technical questions about the network technologies from me, so okay, I don't ask those. This is the contents of my presentation. First, I will have a look at the current situation with the internet, with the home desktop PCs, what's wrong with those. Then I will introduce our Supermatrix program. And finally, I will give you some more details about this virtualization technologies. And anytime you have any questions, please ask. Current status of the internet is one of the issues at this moment, because the structure of the internet is very hierarchical at the moment. The backbone network, for example, in Finland, it's routed through few main routers, and basically, according to the study from the State Research Center, shows that, for example, less than 1,000 video on demand HDTV users would block the whole network, whole internet in Finland alone. The figure is probably much lower than 1,000, because one HDTV user requires something like 20 megabits bandwidth for one channel and so on. Anyway, that's the main point, that the current internet in Finland at least is not ready for IPTV applications. Second issue is that the bandwidth between the user and the server, the service, is not guaranteed. Most probably it's because of the services located somewhere outside Finland or wherever in the cloud. So the user will not get the guaranteed bandwidth from the endpoint here. And the third issue here is that quite a lot, especially during the past couple of years, the advertisers, they have promised that you get something like 5 megabits per second internet connection. Even that figure is the maximum theoretical speed in the network, and it's really far away from the real throughput of this internet connection. Then, if you look at the home desktop computers, what's wrong with those? The biggest issue or problem here is the complexity of the desktop computers. For us, it may be not a big problem, since most of us at least, we are experienced computer users. But you can think about, for example, some retired nurse who has bought her own PC at home, and she tries to set it up and update all the necessary software and hardware. It's really, I could almost say, impossible for her to manage this complexity there. For example, the system may ask that should I allow some traffic to some IP TCP ports, that, and I think it's not within her limits to do this. And also, I'm sure that there are many of us here in this room who has given some support to the relatives or some friends that have bought their PC, and you need to advise them about many issues that they face with the user. At least my mother is such that I get a call from her every few days, and then she asks me something very difficult to answer because over the telephone it's not so easy. Second, one other important issue, problem with the desktop computers, is the security issue. People are not taking backups. So is there anybody here that can say that you have really good backups, data backups of your home computer? Okay. We are very kind of sophisticated users here in this room, I guess, but still I think that most of the users, at least normal home users, they are not really taking good backups every day from easy. Some other issues can be like idle time. You buy this expensive hardware, and most of the time it's just nobody is using it. Okay, you can say that you are downloading some internet, but not everybody is doing that. So point is that you have a hardware resources, but the utilization rate is quite low. Yeah. And you can also say that it's pretty expensive, this hardware, at least the software that you buy for the home. All right. Second part is to introduce our Supermatrix project. And we have three main objectives within this project. First one is to improve our backbone network to face the kind of requirements of the future applications. So it means that there needs to be matrix structured instead of a hierarchical network, so that we don't have any single bottlenecks there. Instead of using this kind of a tree-like structure, we create much more links in the backbone network between the main routers and areas in this network. Second objective is this to bring 100 megabits plus fiber optic connection to every home, at least in our area that we represent here. This can be even faster, it can be a gigabit, and then probably the technical implementation will be gigabit implementation, and then we can leave it at 100 megabits. And third one is this to provide this virtualized computer as a service to these users, and this is only possible if we have this kind of a good, very fast home connection, the internet, and also the backbone network need to support this virtualized computer. Otherwise, it's not possible to do this. Matrix structured networks. Because of these new applications, I already mentioned this IPTV or HDTV applications, video on demand type of applications that require lots of bandwidth, and also I would add this virtual computer service to this list, because often it requires lots of bandwidth, and especially it requires a very low latency in the network. This can be done with a matrix structured network. It can be done also with the local services. We need to place the data centers and services closer to the user. They cannot be in some other country or in Helsinki or some areas in Finland. They need to be quite close to the end user there. And also this makes sure that we don't have any network bottlenecks in this architecture that doing us 100 megabits for home users. This is also the kind of a general target for our government. I think that they have said that every home needs to have this 100 megabits connection. And also, this is for Supermatrix, this other target here is that it needs to be guaranteed bandwidth between the end user and the nearest Supermatrix data center here. So it means that most probably we need to, this kind of operator needs to have this data center and the user in the same network, and they can take care of this point-to-point connection between the user and the data center. Otherwise, it is not feasible, at least not so easily. And third point is that the latency from the user to the data center needs to be minimal. And I'm talking about clearly less than 5 milliseconds latency. Otherwise, the usability of this virtual computer is not good enough anymore. Okay, this is like a general overview of our Supermatrix network architecture. You can see the yellow bubbles here. They are the main user groups. Home users are our main target here, definitely. Small businesses, they are our second target. Some companies that don't have their own IT department, for example, they may still outsource IT operations to Supermatrix type of a service provider. Then there might be some other users. Good example might be like senior citizens' homes, some maybe not hospitals, but some other local government operations, whatever. This is something we are kind of trying to find ideas at this moment also. So the users are here, low-hand side. Then we have this matrix networks. They are like local clouds here, connected in a matrix to each other. And the closest Supermatrix data center is located in the closest cloud, close to the end user, and then the clouds are connected with each other. And they also have their own Supermatrix services there. And most of the services are located in the local center, but it doesn't say that we don't have to put them all there. We can use also some other services, put some services to the next local clouds, for example, and so on. And then, of course, we can use some regular services from the internet also, like Google or whatever. I think it's talking from that. And of course, all this is connected with the internet. And the remote users, they access also their data through the internet and can access, for example, their files with a mobile device or laptop when they're traveling and so. But the service level is not as good for the remote users as it is for the home users, because the network connection is not as good as at the home. This is our setup for the project. As I said, we are a 3-year project, and it is mostly funded by companies. There are some Finnish-based multinational companies like Nokia, Siemens, Network, Tieto, some international companies, mostly hardware, software vendors like IBM, Hewlett Packard, etc. Then some IT companies, integrators, Ainacom, CCC, Finland. And then most of the Finnet group companies, these are telecom operators, quite small in their size, but quite many in their number. So they are the biggest part of the companies involved in the project. And then, of course, as you mentioned, TREX, who is funding also this project. And all this is led by Finnet Association, so kind of a project manager and administration is provided by them. A few more details about this virtualized computer offered by Supermatrix. The main idea is here is that we have the user and we have the user interaction devices here like display, keypad, mouse, etc. And then we have the computer is in the local Supermatrix data center. And we can say that we have extended the cables, display cables, keyboard cables, etc. so that they can locate a few kilometers from each other as well. It's quite simple, and this is a fast network here. And the user interacts with the computer as normal here. And probably we will have a virtualized operating system here, virtual desktop. I'm not saying that we will have a Windows here, but it is one of the possibilities here. And as Windows is also. So the idea is that provide similar services as desktop service computer provides, but with different technologies. So that for user, it should be very similar to using this kind of virtual computer. Here's another example of how we can use the virtual computer. It can be also a virtual set-top box. So instead of having your set-top box with all the recording capabilities, tuners and so on, you can put it in the local data center also. It can actually be the same computer as you're using for your desktop. You can use the same computer for this set-top box, meaning that you can watch IPTV through this computer, and you can order some video on demand services, etc. like that. So no need for set-top box even anymore with this.